What if I told you that everything you see around you is just the beginning? Hidden beneath the surface of our world lies an entire universe of incredible detail and complexity. Welcome to the invisible world that microscopes reveal. From the tiniest bacteria to the intricate structure of materials, microscopes have been unlocking secrets for over 400 years. Since the 1600s, these incredible instruments have transformed our understanding of science, medicine, and the natural world. Today, we'll explore how these amazing tools work and why they're essential for modern discovery. Let's dive into the incredible technology that lets us see what the naked eye cannot. At its core, a light microscope uses a simple but brilliant principle: bending light to magnify tiny objects. Light passes through your specimen and enters the objective lens, which creates the first magnified image. This image is then further magnified by the eyepiece lens, giving you the final enlarged view. Total magnification equals the objective lens power times the eyepiece power. Most light microscopes can magnify objects from 10 times to about 1,000 times their actual size, but magnification isn't everything. Resolution, or the ability to distinguish fine details, is equally important. Light microscopes are limited by the wavelength of visible light to about 200 nanometers resolution. Key components include the light source, condenser, stage, objective lenses, and eyepiece. The condenser focuses light onto your specimen, while the stage holds and positions your sample. Multiple objective lenses on a rotating nosepiece let you quickly change magnification levels. Light microscopes come in several varieties, each designed for specific applications. Fluorescence microscopes use special dyes that glow under specific wavelengths, revealing cellular structures in vivid detail. Phase contrast microscopy enhances transparent specimens without staining, perfect for observing living cells. When light microscopes reach their limits, electron microscopes take over, using beams of electrons instead of light. Transmission electron microscopes can magnify specimens up to 2 million times with incredible resolution. Scanning electron microscopes create detailed 3D images of surfaces at the nanoscale level. While electron microscopes offer superior magnification and resolution, they require special sample preparation and cannot observe living specimens. Scanning probe microscopes take us even further, actually feeling surfaces at the atomic level. An atomic force microscope uses a tiny probe to map surface topography with atomic precision. Scanning tunneling microscopes can even manipulate individual atoms, opening doors to nanotechnology. Proper sample preparation is crucial for quality microscopy results. For light microscopy, specimens are often stained with dyes to enhance contrast and highlight specific structures. Samples must be thin enough for light to pass through, typically just a few micrometers thick. Electron microscopy requires more complex preparation, including dehydration and coating with conductive materials. Specimens are often coated with gold or platinum to prevent charging under the electron beam. For transmission electron microscopy, samples must be cut into sections just nanometers thick. Observing living specimens requires special techniques to maintain cell viability during imaging. Environmental chambers control temperature, humidity, and gas composition for long-term live imaging. In medicine, microscopes are essential for diagnosing diseases and understanding how treatments work. Pathologists use microscopes to identify cancer cells and determine the best treatment approaches. Blood tests rely on microscopic examination to detect infections, anemia, and other conditions. In biological research, microscopes reveal how cells function, divide, and interact with their environment. Scientists use advanced microscopy to understand protein structures and develop new medications. Microscopes help us understand how organisms develop from single cells into complex life forms. Materials scientists use microscopes to analyze crystal structures and develop stronger, lighter materials. The computer industry depends on microscopy for quality control in semiconductor manufacturing. Microscopes are essential for nanotechnology research, helping create materials with revolutionary properties. Environmental scientists use microscopes to monitor water quality and identify harmful microorganisms. Soil health assessment relies on microscopic analysis of beneficial bacteria and fungi. Despite their power, microscopes have limitations that scientists are constantly working to overcome. High-energy electron beams can damage delicate biological specimens during imaging. Sample preparation can sometimes create artifacts that don't represent the natural state of specimens. Super-resolution microscopy techniques are breaking the traditional limits of light microscopy. Methods like STED and PALM can achieve resolution below 50 nanometers using visible light. These techniques allow us to observe molecular processes in living cells with unprecedented detail. Artificial intelligence is revolutionizing microscopy with automated analysis and enhanced image processing. Correlative microscopy combines multiple techniques to provide comprehensive views of specimens. Future quantum microscopy may push the boundaries even further, revealing details we can barely imagine today. From the first simple lenses to today's cutting-edge instruments, microscopes continue to transform our world. They fuel discoveries in medicine, biology, and material science that improve lives and advance human knowledge. Modern microscopy pushes the boundaries of what we can see, reaching into the nanoscale realm of atoms and molecules. Whether you're a student, researcher, or simply curious about the world around you, microscopes offer a window into the invisible universe that surrounds us. The next time you look through a microscope, remember that you're using technology that has revolutionized human understanding. Thanks for joining us on this journey into the microscopic world. Subscribe for more explorations of the science that shapes our lives.